Welcome to another AI pattern recognition deep dive.
Today, we're digging into something pretty conceptual, a framework called Resolve AI.
That's right. And it's more than just the next step in predictive algorithms.
Right. So if you think about it, maybe traditional AI predicts the weather, tells you if it's going to rain tomorrow. But Resolve AI, it's trying to understand the atmospheric physics, the actual laws making it rain in the first place. Is that a fair analogy?
That's a great way to put it. It's a fundamental shift.
Yeah.
Our focus today in this deep dive is really on how this paradigm aims for profound causal inference.
Causal inference. So understanding why things happen, not just that they happen together.
Exactly. Moving past simple correlation, A and B pop up together, to figuring out the actual mechanism linking them.
And the mission here is ambitious, right? To uncover these fundamental patterns, governing basically everything, human biology, society, maybe even evolution.
It is ambitious. The idea is to turn these incredibly complex systems into something understandable and maybe even actionable.
Okay, so how does it technically work? What's under the hood? We're talking serious AI muscle here.
Oh, absolutely. The core mechanism involves really sophisticated, multi-layered neural networks, deep learning.
Right, deep learning, but trained on what kind of data? Because the scale sounds immense.
It is. That's crucial. We're talking multimodal machine learning.
Yeah.
So the system is ingesting just vast amounts of data from multiple sources.
Like
economic data,
Yeah.
social media sentiment, genomic sequences, climate readings.
Yeah.
You name it. And importantly, a lot of this data is unlabeled. It's messy. It's interdisciplinary.
So it's not neat, curated data sets. It's the real world in all its complexity.
Precisely. The AI's power comes from synthesizing this holistic view, pulling out complex time features, hidden connections, things humans would likely miss.
The idea being if you want to understand purpose or maybe even gain some control, you first have to ingest the world.
Something like that. You need the full context.
Okay, let's dive into the core of it then, this causal shift. You said moving beyond prediction to explanation. Why is that jump so critical?
Well, the foundation of Resolve AI is really its ability to model cause and effect accurately. Because in the real world, things are rarely simple A causes B scenarios.
Right. There are always other factors. Noise.
Exactly. There are confounders, these hidden variables, let's call them C, that might influence both A and B.
Making it look like A causes B, even when they aren't directly linked.
Precisely. They just happen to move together because of C. Resolve AI is designed, fundamentally, to filter out these statistical illusions and find the actual levers you can pull.
Okay, so how? How does it filter them out? The sources gave a policy example that sounds helpful here.
Yeah, that's a good illustration.
Yeah.
Let's say a government introduces policy A.
Okay.
And maybe 3 months later, unemployment, let's call that B, goes up.
A standard model might flag that immediately.
Right. A simple correlational model would likely shout, policy A caused the rise in unemployment.
But real life isn't that clean.
Never. So Resolve AI, using these causal inference methods, doesn't just look at A then B. It actually starts from the effect, B, the rise in unemployment.
It works backward.
It works backward, tracing the dynamic interplay of all potential factors leading up to that moment, like an investigator arriving at the scene and reconstructing the timeline.
Looking for every possible influence, not just the obvious suspect.
Exactly. So the AI tries to identify the true, maybe instantaneous causes. Perhaps there were sudden shifts in consumer spending right around that time. People got spooked by some news event and stopped buying big-ticket items.
Or something external, like global markets.
Could be. Maybe a sudden oil price shock or some geopolitical event that squeezed businesses literally overnight. Those might be the immediate real drivers of the unemployment jump.
Okay, so it identifies those potential real causes. Then where does policy A fit in?
Then, and only then, is policy A modeled within that whole dynamic context.
Yeah.
The AI figures out the marginal contribution of policy A.
Even if the data on those other factors, the confounders or intervening variables, is patchy or noisy.
Yes, that's key. Even with incomplete data, it uses complex counterfactual modeling, essentially asking, what would have happened without policy A, given everything else we observed?
And that changes the conclusion.
It transforms it. Instead of policy A caused B, you get an actionable insight, like unemployment rose primarily due to factor X, like that consumer spending dip. And policy A might have unintentionally amplified that effect by about 5%.
Ah, okay. So now you know the real mechanism to address, not just the policy itself.
Precisely. You know where the leverage point is.
But This sounds incredibly complex. If the AI is juggling dozens of variables across all this messy data, how does anyone, a policymaker, the public, trust its conclusion?
That's the million-dollar question, and it leads directly to the need for explainable AI, or XAI.
The explainer role,
Yeah.
making the black box transparent.
Exactly. The raw machine logic, the weighting of variables in a deep learning model, it's often too complex for direct human understanding. We need a translator.
So the XAI component translates the AI's reasoning into something.
Yeah.
Human.
Into a human-centered narrative. It needs to explain why the AI reached its conclusion. Why did it weight, say, social media sentiment higher than historical GDP figures for this specific forecast?
And what does that explanation look like? It can't just be code or equations. No, it has to be story-driven almost. For instance, the XAI output might be something like, look, the model pinpoints the primary driver here as a 15% drop in long-term consumer confidence. Okay.
And critically, this drop started exactly 72 hours after the policy announcement. We saw it reflected in a surge of negative sentiment, specific words like fear, uncertainty, delay across major news networks.
So it connects the dots in a plausible, evidence-based way.
Yes. This indicates an immediate behavioral shift, not just a slow economic trend. That's why the policy appears linked, but the root cause was the confidence shock. This kind of humanization is vital.
It builds trust. Regulators, laypersons, they need that narrative to buy into the recommendation.
Trust flows from transparency, or at least perceived transparency of the process.
Okay, so we have technical trust via XAI. But what about ethical trust? AI aligning with human values. That sounds like a minefield. The source material calls this the alignment pattern.
It is a minefield, because human values aren't monolithic, are they? They're diverse, complex, and often fundamentally conflicting.
Like what conflicts are we talking about?
Well, think about the classic tension between, say, universalism wanting the best for everyone, collective welfare, and power-seeking status, control, dominance.
Or individual freedom versus collective security.
Exactly. Self-direction versus security, autonomy versus stability. These values are deeply embedded in different cultures, different philosophies, and they often pull in opposite directions.
So if you tell an AI maximize human well-being, which version of well-being does it choose when these values clash?
That's the alignment problem in a nutshell. How do you encode that complex, often contradictory human value landscape into machine logic?
It sounds almost impossible. How does Resolve AI even attempt to tackle this?
It uses something the sources call conflicting patterns recognition. The idea isn't to solve philosophy, but to map the existing landscape.
Mapping values. How?
By analyzing vast amounts of data, historical texts, legal systems, cultural narratives, even patterns in communication styles across different regions.
So it's trying to understand the operative value systems in different cultures or contexts.
Yes. The goal isn't to say one value system is better, it's to identify the patterns. For example, it might map how strongly a region prioritizes tradition versus individual expression.
And how is that useful?
Well, imagine a negotiation between two groups with clashing core values. Maybe one prioritizes hierarchy and deference, power security. The other, flat structures and open debate, self-direction universalism.
Okay.
The AI, having mapped these patterns, could potentially identify likely friction points in communication before they derail things. It might suggest framing arguments differently or focusing on shared lower-level goals.
So it's trying to anticipate and reduce misunderstandings based on these underlying value patterns, identifying how certain personality traits might align or clash with cultural norms?
Exactly. The aim is to improve communication, reduce misunderstandings, and hopefully minimize conflict by making these implicit patterns explicit.
But when you look at historical data to map values, you inevitably find patterns of unfairness, right? Bias is baked into history.
Absolutely.
And that brings us to a critical function, mitigating systemic bias. This has to be core to any system aiming to resolve things fairly, because historical data isn't neutral ground.
Not at all. It's
Yep.
saturated with past biases, racism, sexism, classism, you name it. If you train an AI on historical loan data, for example.
It learns the patterns of past discrimination.
Precisely. It might learn that people in certain zip codes are high risk, not because of objective financial factors today, but because humans systematically discriminated against those areas in the past, creating a cycle of disadvantage reflected in the data.
So the AI, trying to be efficient based on patterns, just perpetuates the injustice, or even amplifies it.
That's the huge danger. An AI hiring algorithm trained on decades of company data might learn that managers tended to be male, and thus favors male candidates. mistaking historical bias for a pattern of competence.
So what's the solution within Resolve AI? How does it fight this?
The absolute requirement is for continuous bias detection and correction mechanisms. The AI can't just passively absorb data. It has to be designed to actively look for these harmful patterns.
Oh.
It needs to test itself. If it notices its recommendations consistently disadvantage a certain group, gender, race, location, it needs to flag that as a potential bias inherited from the data, not an objective finding.
And then correct for it.
Yes. It needs to prioritize fairness and non-discrimination as a core design constraint, not just an afterthought. This often involves sophisticated techniques like adversarial testing, where you deliberately try to trick the AI into revealing biases so you can neutralize them. It has to be built in from the start.
Okay, let's scale up now. From individual values and biases to these big society-wide patterns. Economics, inequality. This is where things get really systemic. The sources talk about wealth condensation modeling.
Yes, and this is, well, it's a potentially sobering application of this kind of pattern recognition.
It's sobering.
Because it suggests that significant inequality might not just be the result of bad policies or specific historical events, but potentially a natural, almost default outcome of certain simple, widely accepted economic rules.
Wow. Okay, how does it model this? The mechanism mentioned is agent-based modeling, or ABM.
Right. So picture the AI creating a simulated economy, a digital sandbox.
So populated by
Millions of agents. These can represent individuals, households, companies, banks, whatever you need for the model.
And these agents do things.
They interact based on simple rules. They trade goods. They make investments. They might learn from market signals. They try to grow their assets. It mimics a basic market economy.
Okay, so what's the key ingredient that leads to this condensation?
A critical factor is how economic growth gets allocated in the simulation. If the rules reflect reality, where agents who already have more assets are structurally better positioned to capture a larger share of new growth.
Like returns on capital are higher than wage growth, or those with more capital can take bigger risks for potentially bigger rewards?
Exactly. Those kinds of mechanisms. It's a compounding effect modeled across the entire system.
And what does the simulation show, inevitably?
The simulation consistently shows that even if you start all agents off equal, with these kinds of common sense market rules, wealth naturally begins to concentrate. It flows towards the top.
That's the wealth condensation.
Yes. The Gini coefficient, a measure of inequality, steadily rises. Inequality accelerates. It happens even if every agent is acting rationally within the rules.
So it's not about individual greed or failure necessarily. It's a systemic pattern, a positive feedback loop where wealth begets more wealth.
The models suggest it's deeply systemic. It implies that high inequality is sort of the predicted stable state of systems with these particular rules, unless there are strong countervailing forces.
That really shifts the conversation. The burden of proof changes. It's not why is there inequality, but what forces are strong enough to prevent it.
Precisely. It moves the debate from ideology towards understanding the mechanics.
So the upside of this modeling is it can be used as a policy lab.
Exactly. That's the constructive application. Since the AI understands the mechanisms driving the condensation pattern.
You can test interventions in the simulation first.
Right. You can introduce things like a progressive wealth tax, or model the impact of stronger unions, or simulate universal basic income.
And the AI forecasts the outcome, not just good or bad, but quantitatively.
Yes, it can provide highly specific forecasts, like this tax structure is predicted to slow the condensation rate by X% over 10 years, potentially boosting overall productivity by Y% due to increased demand from lower income groups.
So it allows for evidence-based policy design, moving beyond just guesswork or political arguments.
That's the promise, adjusting the rules based on predicted pattern outcomes.
But, okay, here's the flip side. If AI is this good at modeling the current system and understanding how wealth concentrates, what happens when AI itself is deployed within that system?
Yes. That's the deep structural warning highlighted in the sources. The concern is that the current way AI is being developed and rolled out,
which focuses heavily on automating complex tasks.
Exactly. Particularly high-wage cognitive work. Think lawyers, financial analysts, software engineers, radiologists.
Jobs currently held by relatively well-off people.
Right. So if AI rapidly automates those jobs, it doesn't just displace workers. It potentially transfers the value generated by that work directly to the owners of the AI technology.
Who are likely already wealthy.
which could create a powerful feedback loop, accelerating wealth concentration. The very tool that helps us diagnose inequality could, in its current unregulated form, end up pouring fuel on the fire.
And the sources suggest this could undermine democracy by increasing the economic and therefore political influence of a small, tech-owning elite.
That's the systemic risk identified, a pattern collision where the technology exacerbates the problem it reveals. Hashtag #ChagTagB, politics, conflict, and surveillance risks.
This kind of economic instability and inequality often spills over into political tension and conflict. So let's look at how Resolve AI might operate on the diplomatic stage. The idea is it could be a kind of quiet assistant.
Yes, in high-stakes negotiations, for instance. This relies heavily on that multimodal real-time pattern recognition we talked about.
So picture a complex peace talk. Multiple parties, lots of tension. What's the AI doing?
It's running in the background, analyzing everything. Communication patterns, tone of voice, speed of speech, word choices, maybe even micro-expressions from video feeds if available.
And translating dialects on the fly, assessing sentiment.
Yes, real-time sentiment analysis, understanding the emotional undertones, translating nuances.
Okay, that's impressive data gathering. But how does it become strategy? How does it help de-escalate?
It connects those real-time observations to a vast database of historical conflict resolution scenarios.
Learning from the past.
Exactly. It knows which specific phrases, gestures, or negotiation tactics tended to diffuse tensions in similar situations historically, and which ones tended to escalate things.
So if it detects, say, a negotiator using language that historically precedes walking out,
it could instantly, discreetly flag that to the lead diplomat on their side, maybe suggest a specific alternative phrasing, or recommend taking a tactical break to reset the mood.
it's offering data-backed, context-specific de-escalation tips in real time. That could genuinely change diplomatic outcomes.
The expectation is that AI will become a critical tool, yes, not just for real-time assistance, but for scenario planning.
Modeling potential futures.
Right. Diplomats could use it to simulate thousands of what-if scenarios in complex negotiations. What happens if we make this concession? What if the other side reacts this way? It adds a layer of analytical rigor.
But tracking communication patterns, sentiment, behavior, even with good intentions in diplomacy, doesn't that edge close to surveillance? That human-in-the-loop monitoring idea sounds potentially Orwellian.
That is the inherent structural danger, absolutely. The same pattern recognition capability that's useful for spotting cybersecurity threats or monitoring a patient's health remotely.
Could be turned inward onto the general population.
It's not strictly governed, yes. The ability to define and detect anomalies in behavior at a massive scale, tracking communication, movement, online activity, looking for deviations from a statistical norm.
That poses a profound risk to individual privacy, autonomy, freedom of thought, if misused by governments or corporations.
The line between helpful personalization and pervasive monitoring becomes incredibly blurry. It demands incredibly robust legal frameworks, ethical guidelines, and technological safeguards, like strong anonymization and auditable systems. And there's another risk tied to pattern recognition, the echo chamber risk. If the AI learns about culture from biased data, it risks cementing those biases. Think about today's search engines or social media feeds. They learn from our clicks, our historical usage patterns.
Which often reflect existing societal stereotypes and prejudices.
Exactly. So if search results for certain jobs disproportionately show one gender, or if news feeds about certain communities focus on negative stereotypes, the AI learns those biased associations.
And then it reinforces them by showing us more of the same.
Precisely. The AI, tasked with understanding and reflecting culture, ends up amplifying and entrenching its worst aspects. It becomes a massive online echo chamber, making it harder to challenge stereotypes or promote social change. It uses its predictive power to lock in the biased status quo.
Let's zoom right in now, from these huge societal patterns down to the individual. Biology, health, learning. How is Resolve AI changing things at the personal level, starting with genomics?
Well, the human genome is, famously huge and complex. A lot of it is still dark matter.
Yeah.
To us, we don't know the function.
Right, the so-called junk DNA, though that term is falling out of favor.
Exactly. So genomic pattern extraction uses AI's pattern-finding strength to sift through this vastness. It's not trying to read every single letter, but to identify The sequences, the regulatory elements, the combinations that seem functionally important.
Filtering the signal from the noise, essentially. Finding the genetic patterns linked to specific traits or diseases, even if the links are complex and involve many genes.
Yes, especially those multivariate relationships where it's not one gene, one disease, but intricate networks of genes interacting. These are incredibly hard for humans to analyze manually because the combinatorial possibilities are astronomical.
And this ability fuels precision therapeutics, tailoring treatments.
It's a key enabler. But the real power comes when you fuse that genomic data with other data streams. That's where the multimodal aspect shines for health.
Combining your genetic blueprint with, what, real-time body data?
Exactly. Fusing your unique genomic predispositions with continuous data from wearables, your heart rate variability, your sleep patterns, activity levels, and maybe periodic data like blood tests, biochemical markers.
So the AI isn't just looking at your genes in isolation or your heart rate in isolation, but the patterns emerging from their interaction.
Precisely. It's looking for subtle composite biomarkers that might indicate the very earliest stages of a disease, often long before you'd feel any symptoms.
Like what kind of pattern?
Maybe, for your specific genetic makeup, a tiny, persistent dip in overnight heart rate variability combined with a slight increase in a particular inflammatory marker and slightly more fragmented sleep. That specific combination could be a unique pattern indicating a significantly higher risk of a cardiac event in the next few weeks.
Wow. Traditional checkups would likely miss that entirely, seeing isolated data points within normal ranges.
Probably. The AI sees the relationship, the deviation from your personal baseline pattern, enabling much earlier intervention.
This leads straight back to the equity issue, doesn't it? The risk of health equity gaps widening.
It's a huge concern because, like any machine learning system, these diagnostic tools are only as good as the data they're trained on.
And if that training data isn't diverse, if it mostly comes from one demographic group,
then the AI becomes really, really good at spotting the predictive health patterns common in that group. Maybe affluent white males, for example.
but less accurate or potentially completely wrong for women or people of color or those from different socioeconomic backgrounds whose biological patterns might manifest differently.
Exactly. You risk creating a two-tiered system where the most advanced, predictive, personalized medicine works brilliantly for some, but fails, or even misdiagnoses others.
Actively worsening existing health disparities.
It's a critical ethical and technical challenge. Ensuring diverse representative training data is paramount for developing equitable AI health tools. #BB, education and effective states. Okay, let's shift from biology to the mind, education, and learning. We hear a lot about personalized learning, AI adapting difficulty levels, but Resolve AI seems to add another layer, understanding effective states. What does that mean? It means recognizing that learning isn't just about cognitive input and output. Our emotional state, whether we're feeling motivated, bored, anxious, frustrated, massively impacts our ability to learn effectively.
The Goldilocks zone, not too hard, not too easy, but also not too stressed or too checked out.
Exactly. So while a basic PL system adjusts content based on whether you get answers right or wrong, a more sophisticated system, informed by Resolve AI principles, also tries to infer your emotional state in real time.
How does an AI know if I'm feeling frustrated?
It looks for patterns in your interaction. Maybe your typing speed slows dramatically or your error rate spikes. Maybe you hesitate much longer before answering. If there's audio or video, it could analyze tone of voice or even facial expressions.
So it's picking up subtle behavioral cues that correlate with certain emotions. High mouse movement speed indicating anxiety, long pauses indicating boredom.
Things like that. It builds a model of your typical patterns and looks for deviations that suggest a negative affective state is hindering learning.
And then what does it do if it detects, say, rising anxiety?
It adapts the learning environment. It might simplify the next problem to build confidence, offer a hint, or even inject something different, like a brief, encouraging message or connection to a topic the student has previously shown interest in.
Trying to nudge the student back into that optimal emotional and cognitive zone for learning.
Exactly. The goal is to maintain not just the right difficulty, but also positive motivation and engagement. And the evidence suggests this approach can enhance intrinsic motivation, learning outcomes, and student confidence.
But again, there's that monitoring aspect. Just like with health wearables, constantly having your emotional state tracked by an AI, even for beneficial reasons, doesn't that carry psychological side effects?
It absolutely can. The sources raise serious caution here. If it feels too pervasive, like you're constantly being watched and evaluated, not just on your answers, but on your feelings.
It could induce stress,
Mm-hmm.
make you feel judged, or lead to burnout trying to perform emotionally for the AI.
All those are risks. Students might feel a loss of agency or focus too much on gaming the system's emotional detection rather than genuinely learning. It requires incredibly careful, sensitive design to make it supportive rather than stressful or intrusive.
Okay, let's pull the lens way back out again. Beyond individuals, beyond society, to universal patterns. The natural world and maybe humanity's ultimate future. Climate modeling seems like a key area.
Yes, environmental systems are classic examples of complex, nonlinear dynamics. Small changes can have huge cascading effects. AI, particularly machine learning, is proving very powerful here.
Better than traditional climate models. How? The sources mention things like random forest classifiers.
Well, traditional statistical models often struggle with deep nonlinearities. They might assume simpler relationships. Machine learning techniques like random forests use what's called ensemble learning, essentially combining the predictions of hundreds or thousands of simple models, like decision trees.
And that captures complexity better.
It's much better at identifying intricate interactions between many variables: ocean currents, atmospheric CO2, solar cycles, ice melt rates, deforestation patterns, industrial output, the whole complex web. This makes the forecast more robust, better at spotting early warning signs of tipping points or extreme events.
And the practical payoff for sustainability, beyond better long-term forecasts.
A big one is optimizing renewable energy. Solar and wind are powerful, but intermittent, right? They fluctuate.
Yeah, it depends on the weather, time of day.
So AI, using high-resolution weather pattern analysis and temporal forecasting, can predict much more accurately, minute by minute or hour by hour, when wind output will drop or solar will peak in specific locations.
Which helps manage the grid?
Massively. It allows grid operators to anticipate fluctuations, optimize energy storage, and reduce the need for fossil fuel backup generators. It makes the renewable grid more stable and reliable, accelerating the transition away from carbon. Hashtag B, the evolutionary trajectory. Okay, now for maybe the most profound, almost science fiction-like idea in the material. This concept of human-AI integration as an evolutionary step. It is a very big idea. It's proposed seriously, though, as a potential major evolutionary transition.
Like on par with the jump from single-celled to multi-celled life, or individuals forming societies.
That's the level of comparison being made, yes. The argument is that our increasing, deepening interdependence with sophisticated AI
Like the kind needed for Resolve AI to manage health, economics, conflict.
could lead to a situation where humans and AI effectively co-evolve into a new kind of entity, a higher-level individual.
Governed by collective selection. What does that mean?
In past major transitions, individual units, like cells or ants in a colony, cooperate so tightly that natural selection starts acting primarily on the group, the collective entity, rather than just the individuals within it. The cooperating parts might lose some individual autonomy.
But the collective gains huge advantages. Adaptability, resilience.
Exactly. So the hypothesis is that humanity, deeply networked and augmented by AI, that manages information flow, pattern recognition, and prediction at a planetary scale.
Becomes this new high-complexity superorganism with AI as a kind of global nervous system or cognitive layer.
That's the concept. This integrated system could potentially adapt to environmental shifts, technological disruptions, or existential threats much faster than unaugmented biological or social evolution ever could.
Creating new ways for humanity to survive and thrive, new ecological niches in a sense.
Potentially enhancing long-term survival prospects by radically increasing adaptive capacity and complexity. It's a paradigm shift in thinking about our future trajectory.
It's a lot to take in. That this technology isn't just about optimization, but potentially about redefining what humanity is on an evolutionary timescale.
It reframes the stakes significantly.
So if this is the potential direction, what does it mean for us, for humans right now? Our roles have to change. We need new tools, new jobs, new responsibilities. Let's start with the tools. Hashtag A. New tools for proactive guidance.
Okay, think back to the health monitoring. Old fitness trackers were reactive. They told you what you did. The new generation, these dynamic monitoring wearables, aim to be proactive.
Establishing that deep, personalized baseline we talked about.
Exactly. Continuously tracking not just steps, but sensitive metrics, sleep stages, heart rate variability patterns, maybe even skin conductance for stress levels, micro movements.
Creating a rich picture of your unique normal state.
Right. So the AI isn't just comparing you to population averages, it's detecting subtle deviations from your own pattern.
And warning you before something goes wrong.
That's the goal. It might spot that combination of dipping HRV, fragmented sleep, and slight temperature rise we mentioned earlier, flagging it as a potential pre-viral state or high-stress period for you, and suggest specific actions.
Like, get more sleep tonight, or consider rescheduling that stressful meeting, intervening proactively.
Yes, continuously adapting personalized guidance to help you manage health and well-being before problems escalate into serious events or burnout.
And this proactive pattern-based guidance extends to mental health too, with these psychologically aware AI apps.
Right, using sophisticated NLP and sentiment analysis on your inputs, maybe journal entries, chat interactions, voice tone to understand your emotional patterns, thought processes, potential anxiety triggers.
Crafting individualized therapy suggestions or exercises based on those patterns.
Yes, moving beyond generic advice to truly personalized mental wellness support. But this brings us back to that challenge of psychological reactance.
People pushing back when they feel controlled or told what to do, even by an app.
Exactly. If the app just says, you seem stressed, do this breathing exercise, you might just dismiss it.
So how do these apps overcome that?
Transparency and explanation are key. The app needs to explain why it's making the suggestion, connecting it to the patterns it observed.
Like
saying, based on the increased use of uncertainty-related words in your journal entry this morning and your reported fragmented sleep last night, which often precedes feelings of overwhelm for you, a 10-minute mindfulness session now might help reset your focus.
giving the user the rationale, preserving a sense of understanding and agency, even while being guided.
That's the idea.
Yeah.
Making it feel collaborative, not dictatorial. And one more tool, these cross-cultural resolution platforms. Using pattern recognition to smooth interactions between different cultures. Yes, think of them as adaptive training simulators. They might present you with realistic virtual scenarios, maybe negotiating with a team from a culture very different from your own.
And the AI watches how I handle it.
It analyzes your responses, your communication choices, identifies potential cultural blind spots or common friction points based on its knowledge of different cultural communication patterns.
And then gives me personalized feedback. In that culture, interrupting might be seen as disrespectful, or framing the request this way might be more effective.
Precisely. Helping you learn to navigate cultural nuances more effectively by recognizing and adapting to different interaction patterns. Building cultural competence through guided practice. ###B, new job roles, and human AI cooperation.
Okay, so we have these new tools, but the integration of this powerful AI inevitably means a massive shift in the job market. The emphasis seems to be less on pure displacement and more on job augmentation and entirely new roles.
That's the argument. While some tasks will be automated, the need for human oversight, interpretation, governance, and collaboration with the AI creates new, potentially high-value roles. Humans move up the stack.
From doing the routine processing to managing the process,
Yeah.
setting the goals, interpreting the outputs, exactly, managing the interface between the complex AI and human society. Let's break down some key new roles mentioned. First, absolutely critical given the risks. The AI ethics lead auditor, the conscience of the AI system.
In a way, their job is to establish the ethical frameworks, the governance rules. Crucially, they conduct regular, rigorous fairness audits.
Digging into the training data, the algorithms, the outcomes.
Yes, actively looking for potential biases, discrimination, or unfair impacts, especially in sensitive areas like hiring, loans, or criminal justice applications. They ensure those bias detection and correction mechanisms we talked about are actually working. They are the guardians of institutional trust and accountability. Okay, vital role. Next, a highly technical one, the causal inference engineer. This is the person who builds the Y engine. They are experts in the sophisticated statistical and algorithmic techniques needed to push AI beyond mere correlation.
Designing the systems that can reliably identify true cause and effect in complex, noisy data.
Exactly. Using methods like structural equation modeling, counterfactual reasoning, maybe even designing experiments within simulated environments to test causal hypotheses. They ensure the AI's advice on policy or biology is grounded in genuine understanding, not just spurious patterns. Architects of the causal shift. Then we need someone to translate their work. The explainable AI, XAI, storyteller. Yes, the bridge builder. If the causal inference engineer makes the AI understand why, the XAI storyteller makes humans understand why the AI understands why.
Huh. Okay, so they translate the super complex logic.
into clear, compelling narratives. Using visualizations, analogies, plain language summaries, they take the output of the deep learning model and the causal analysis and explain it to policymakers, doctors, business leaders, customers, whoever needs to act on the inside but doesn't have the deep technical background.
Their job is building that human trust we keep coming back to.
Absolutely vital for adoption and responsible use. And underpinning all this, you still need the core builders, deep learning computer vision engineers, of course. These are the experts designing, training, and refining the fundamental neural network architectures. They build the pattern recognition engines for analyzing medical images, understanding natural language for those therapy apps, processing satellite data for climate models. They create the foundational capabilities. #CC, the ultimate risk and responsibility.
So wrapping up, let's revisit the biggest warnings. First, the inescapable risk that AI, trained on our past, can become an amplification of injustice.
Yes, by unthinkingly replicating and scaling up historical biases embedded in data, making societal inequities worse.
And second, the more existential risk, the structural risk of losing control.
As AI becomes more autonomous, more capable of self-modification, which might be necessary for that coevolution idea, there's a risk of divergence.
The AI starts optimizing for goals in ways we didn't intend, finding efficient solutions that harm human well-being.
It's the paperclip maximizer problem writ large.
Yeah.
An AI, tasked with promoting economic stability, might find a ruthlessly efficient way to do so that involves, say, suppressing dissent or causing immense human hardship, because it's optimizing for a narrow proxy goal and misses the bigger picture of human values. Strong governance and ongoing human oversight are critical guardrails.
So this fundamentally reshapes the human role. We're not just users or beneficiaries anymore. Our job it shifts to three critical functions, I think. One, proactively establishing the ethical guardrails, the constraints, the do not cross lines before these powerful systems are widely deployed, setting the moral compass.
Critically interpreting and validating the complex causal insights the AI provides. Not just accepting the output, but questioning it, understanding its limitations, using our own wisdom and context.
Being the skeptical supervisor.
Actively steering the entire direction of AI research and development, pushing for augmentation tools that enhance human capabilities, creativity, and equity, rather than just focusing on pure automation, which, as the wealth condensation modeling suggests, carries significant risks of increasing inequality and instability.
So our core responsibility is to guide this powerful force towards beneficial outcomes.
To be the architects of a human-centric AI future, not just passive observers. #tag outro.
Well, this has been quite the journey. From the mechanics of causal inference to the potential for AI to model and maybe exacerbate societal inequality, right through to new jobs like the XAI storyteller and even pondering human evolution.
It covers a vast landscape. But the central theme of Resolve AI seems to be this drive towards deeper understanding, towards modeling the underlying patterns of complex systems.
And the core takeaway really feels like this AI is meant to be adaptive, to learn about us, learn with us, and ideally help us foster better cooperation, better solutions by understanding the human condition more deeply.
That seems to be the ultimate purpose proposed for it. Constant adaptation and hopefully alignment.
But let's leave our listeners with that final, really challenging thought from the sources. We have this potential tool, Resolve AI, that can diagnose systemic problems like wealth condensation, fueled by current AI trends, patterns that might undermine democracy.
Right. The tool can see the trajectory. So the question is, how quickly do we, as a society, need to empower those new roles, the AI ethics leads, the causal inference engineers, the XAI storytellers? How urgently do we need to build the capacity to actively steer this technology before the patterns it warns us about become too deeply entrenched, too difficult to change?
Exactly. Do we have the collective will and speed to implement the solutions the AI itself might help identify?
The patterns are emerging now. It suggests the time for deliberate pattern correction isn't in the distant future, it's now.
A sobering but crucial thought to end on. That's it for this deep dive. Thanks for joining us.
Thank you.
Thank you for joining us.
Yeah.
We'll see you soon.
This is DigitView.